So you may have heard me use generics in terms of creating generic classes in the last few videos, or you may have just heard about them in general, generic lists or just generics, and wondering what they are. So I thought we'd step back and actually explain them now that I've used them in videos, and some of you might wonder what they are. So let's just create a console app, .NET Framework. This is just so we can create some and do some examples. Just make this bigger. So generics, well, I'll show you what generics are first. So let's just create a class here, my generic class. So there's a regular class. All the generic class is when you do these angle brackets and you put, say, a letter in there or a name in there, and you put whatever you want. So it's like defining a variable. So we'll just call this T, which is the classic generic. It stands for type, I guess, generic type. Same as when you do a for loop, you tend to put an I, it just become standard. So T is the standard thing you do with generics. You just, you don't name it. And now inside this class, I could define a public, say, int my number. And then here, let's remove this first. So it's a regular class right now, and we could make a new version of that, and you just define a new class like that. Let's give it a easier name so it's not a special case. So there's a new class, and we have a number, which is an integer. So to make it generic, I'll get to the reason why you do afterwards, but to make it generic, you do this angle bracket, so you put a variable name there, and now you could change this integer to be a T. So it's a type that we basically know nothing about. This class doesn't have any idea what T is, but you can now create a class and use that. So now, in order to then create a new instance of that class, you also have to provide the variable here, but this time it's the actual type. So let's say int. And now we've got a C, and if we do C dot, you can see we've got my number, and it's actually returning an integer. So even though this class has no idea what an integer is, it can return one. And then in a similar fashion, we could do a generic class of booleans, and in C2.myNumber, it's now a boolean. So that's what a generic class is. So let's explain a little bit about I guess why would you ever pick to do this? And this is just one example of many. And the hardest thing with generics is explaining the reason why you use them. To me, it's like one of those things that's really basic. It's like saying, why would you add two numbers together? It's hard to explain. So I think the simplest way of explaining is, if at any time in your code you have any logic or data or methods that should apply similarly but to multiple types, then you want to use generics. So let's say we have, well, the classic one is lists, which Microsoft have already done. So you'll see me use, say, a equals new list of string, and now that'll make a little bit more sense to you, because now you know list. If we press F12, you can go in and look, it's got a generic list, which implements a generic interface of an I list. And then inside the list, using this generic T, they've returned the type when you do the indexer. When you add, you specify the type that you want to add, and then you implement that. So there's one use of a generic class, and let's just make our own. So let's call this my list, or in this case, let's start without the generics and show you why again. So let's say you have you want to store a list of numbers. So you just have, say, my number list. In this case, let's be more specific. My int list, and this would be say int get number, and the point of get number is going to accept a position, and we're going to have, say, a private, and we're going to try and use a non-list here, because that's already a generic, but let's just use an array then. So my integer array numbers equals, and then for, again, simplicity, just to prove the point, we'll just make a new array for now, just for make a 6 number array. And the function getNumber wants to return basically the position in that array that you ask for. And then you'd have, you know, like addNumber. So say public void addNumber, and you pass in an int because it has to be an int, and you'd add the number. So in this case you wouldn't to this. So let's just change this to, I know we're using generics here, but it doesn't really matter inside. This is just again to prove the basic points, if you will. So we've made a number array. We wouldn't even need that now because we can add. So in the add number, you'd then do mnumbers.add number. So now you can add a number and you can get a number. And let's just check that works. So var numbers equals new myInt list numbers.add 1, 2, 3, 4, 5. And then, well, in fact, let's make these a bit different so that you don't get confused with the get. So now you could do, say, numbers.getNumber at position 3. And then you could just write that out to the console. And then make sure it doesn't close. And if we run that, we should get number 30 output to the screen. Or 40 rather, oh yeah, 0 based index. So we've asked for position 4 effectively because we've done obviously a 0 based index. So we got 40. Now if you wanted to say you got a list of strings that were storing, you know, some information in general, just some maybe text. The only way you'd do that, and you will also want to be able to add a string and get the string, you'd copy and paste the class and you'd change it to my string list, and now you'd go, you want a list of strings, and the list there, and then add number would be add string, say, and this would have to be a string, this would have to be a string, well no, an int is still a position, and then you could do get string, rename this. So you've effectively just copy and pasted all of the code of what was going on in this basic class to add a number and get a number. And now we could do all this over again. We could do strings. We could do A, B, C, D, E. Oh. My string list. Add string. And then you could get the number, you could get the strings, and you'll get 40, and then whatever the fourth one, they get the letter D. This is going really slow. Okay, what's going on there? Oh, I just didn't see it. So, cut that out. So you get 40 and D. And you can see again, this is just a basic example of something that could happen. You wouldn't necessarily just have a list because you've already got a generic list. But the point is, you've got repeatable logic. You've got something that you want to do, in this case, add numbers and get numbers, or add strings and get strings. It's effectively a collection. But you want to be able to add specific types. You know, you want to make sure your string list contains strings only and not numbers. So you can't go and add, say, a number to this list because the class knows it can only accept a string. So you get the compile time error. And that's one of the main benefits of generics, as it can detect at compile time when you're compiling your code if there's issues. So this is what actually happened in the very early days of .NET before generics. Is if you wanted a list of strings, you'd have to create a string list, and then an int list, then a boolean list, and then all the functions would have to repeat themselves. And there's multiple things you could do to try and overcome that, and that was either to change this list to an object so that anything can be added. And if you did that, then it'd be a list of objects. You could only return an object because you don't know what the list contains. So then this would just become my list, say. And this would just be list. And say you wanted numbers here. You could add numbers, but the problem with an object now is you could add a string as well. So that's one problem. Now your list might not be numbers if that's what you're expecting. Object. So you can add anything you like. The other issue is then your get number, in this case, returns an object now. So you can see it returns an object. So if you wanted to then do, I wanted to get, say, the first number and the second number and times them together. So you do that equals get number first one. This is the second one. And then you do result equals, say, f times g, because they're two numbers. And you can't because you're trying to now multiply two objects. So then you have to cast them to integers. Now, you can cast them this way to an integer, and that'll then times. But the issue is, let's say we got 0, 1, 2, 3, 4. We got the fifth index. That'll quite happily compile as if there's no issue. But if you now run this, it's going to crash on this call because you can't convert an object to an integer. So you wouldn't know about this issue until you ran your code, or until your customers are running your code. So this is not really ideal, this way of just doing an unknown type, because there's no limits and there's nothing stopping you doing bad code. So generics come into play to then make this list a true generic list that's type safe, so that you can't do this and you don't have to do this. We can then do a generic list that just simply accepts a type that we don't know of, and inside we're just going to create this list, and then we're also going to accept the type there, and then we're going to get there, and we can now return the type there as well. So everywhere where we had object we can replace with this unknown type of t, and then in the list we can now explicitly say I want it to be of an integer, and now this won't work because it knows. So we get rid of that, and also get number returns an integer anyway, so this isn't needed. So now we can create a list that's got all these functions to add and get and whatever else there were of type integer, and now we could make one of a type string. So you can now do a string list, and then you could just do a list 2 dot add. I know it says number, this is again just an example, but now you can add a string, and you can't add anything else. So that's the point of generics for the most part, is taking in specific types when you create the class, not inside the class itself. So this class is unaware of what type this is, but it can now provide all these functions that it knows what to do anyway. It knows, doesn't matter what this object is, it can still add it to a list inside itself, and you can still get the object. You don't have to know anything specific about it in order to do these functions. So that's sort of the main use of generics, and that's the one you'll see mostly, and like I say, that's the one that's already defined by Microsoft with like lists and sorted lists and linked lists, and you'll see you've got collections as well. You've got dictionaries that have also got generics, and you can see you can pass multiple types as well. It's just like defining a variable. So you could have a list that accepts one thing and another thing and another thing, and then create, you know, a list that's got the secondary type in, and you know, you can do what you like. Just think of these as defining variables inside the class, or types of variables that you can then use however you want, and you don't know anything about them. So that's one way, and that's the lists. Now, real world, because it's never useful to just show kind of pointless examples. So if we open, if you've been following along the videos making Falsetto.word, let's go and take a look now at what we did and why. So in the Word application we've got a login page, and this login page has now got a view model binding. So we're binding to an email, and in the background to do that we would have had to, for this login page, we would have had to then do this .data context, which is the thing that the page is bound to, equals new login view model, and we'd have to set this data context to this view model. Now for every single page in the application it's going to be view models, So for every page we make, the register page, the login page, the settings, the chat, you name it, every page is then going to have a behind code that says this.dataContext that then defines a view model this way. And then if we were to change this or make it more complicated or want to do anything custom that's effectively the same for every page, it's the same and different because it's the same you want to set up a view model for the data context, but the difference is the view model is going to change. The view model can be different. But there is a similar type that this is effectively a view model, and we want to set the data context. So what we did was use a generic base page. So we made a base page which we already had, and all this information doesn't really matter. We've made page load animations, but what we did is then passed in a generic variable name, if you will, a generic type, and we called it VM. And then we made a public property using that type, VM. And then when we get that, we simply just return a private property that's the same type. And when we set it, we basically set the value, and then we set the data context here to the view model. And again, this base page doesn't know anything about the view model. It simply sets the data context when we set that property. And then because we've also passed it into when you create the base page, it's aware of this type. On construction of the base page, we then say, well, in this case then, let's create a new view model. Let's set the view model variable to a new VM. So let's make a new instance of this unknown type. And then when you set that view model, it effectively sets the data context. So then by simply inheriting this base page and saying the type as login view model, what that does now inside this login page is we get access to that view model from the base page. It's already casted for us, if you will. It's already a known type of login view model because we passed it there. So we've got full access to the login view model that we can then get the email from and anything else. And also the data context in the base page constructor has set up our data context to this view model, a new version of this. So this is an actual real world use of a generic. And you'll notice here, this is where you need specific information. So if you just pass in VM, there's nothing known about VM. So if I remove that, you'll notice now we can't do an equals comparison because it knows nothing about the types. So you can't compare a view model of an unknown type with a value of effectively the same thing, but there's still the comparative itself. You can't just do an equals on. You can't compare it's the same. So to do that, you do where, the name of the variable, a colon, and then with comma separations you can define things. So I'm saying the VM has to be a base view model or inherit from it. So if we try to then make a base view model of, say, an int, this will complain that an int isn't a base view model. It will do when I compile anyway. So it's failed here. Doesn't want to jump over to my failed list. Okay, my error list is a bit broken, but you can see here, partial declaration of login page. Oh, we've got to match the types first. So, in fact, let's make this easier. Just make another class here to show you that. Public class A, and we want a base page of integer. And this should now complain at us that, there we go, the type int cannot be used as type parameter. VM is a generic type or method based VM. There is no boxing or conversion from int to base view model. So it's preventing us from defining anything inside the base page that isn't a view model, because that's the purpose of this. So we've defined it as a view model. By defining it as a view model, because that's a class that we made, it's effectively an object. So now we can do a comparison on the objects. So our comparison here is now okay. And then in order to create a new one of it, so in the constructor we made a new VM, again we need to tell it that it actually can be newed up. So we've defined that it's something that you can create a new instance of, and it's also of type base view model. So this is a constraint of the generic. But you can see this is an actual, again, a real world example. This is something we're making that will work and is completely made for its purpose. And generics have solved the issue of having to, in every single page we get, set up the data context. And then obviously this will expand to be much more useful, because now we can do anything on the view model. We could validate it, we could do anything in the base page that's universal to pages that wants to then make use of a view model. So that's a real world example there. We've covered the where clause as well in terms of, defining a little bit about what the VM is. I've mentioned you can just do, multiple parameters that get passed in, and that just is what it is. You pass in another one, you give it another name, and then you can use it inside here just the same. You can do what you like with it. You don't have to pass one type. And a real world example of that would be a dictionary. So if we did a new dictionary, and you can see here there's a key and a value. So you could have a dictionary where the key is an integer and the value is a string. And now the dictionary is generic. You can get the keys, which are integers, and you can get the values, which are strings. So again, inside the dictionary, we just press F12. You can see then they've used the value, which is strings. When you're doing an index to get the value, it returns the value type. And when you're adding, you pass in a key and a value. So again, hopefully that's fairly obvious what they're doing. They're just making use of it as if you would a normal variable. And then another example would be, we haven't got anything in this application yet, because we haven't got that far. But what we will do is when we start having to communicate with the web server, and the web server itself for doing this chat application, the web server is going to constantly return some data. So if we want to ask for the latest messages, or if we want to simply send a message and get the response, or if we want to log in, all of those things are going to be return calls from the website. And every single call from the website, for one, we want to know if it succeeded. For two, we want to know if it didn't succeed, what's the error message. But then thirdly, if it did succeed, we then want the specific piece of information, the data about that message. So if we send a message and it succeeds, we want to know, okay, well, what's my message ID, so I can then add it to the application and reply to that. Or if I log in and it succeeds, then what's my authentication cookie, so I can now save it and then I can log in successfully afterwards. Basically all the web calls, every one will be different, but the similarity with every single one of those is that you need to know firstly if it succeeded, and if it didn't, what was the error. That's a shared common thing between every web call. And that will look like this. So let's say we have a public class, API web response. And that's a class, and you're going to have a boolean if it succeeded. And you'd also have, if it didn't succeed, you'd have an error. And then if it did succeed, you now want this unknown type of response. So you could do an object and do a response, but that's nasty. That's just, you're gonna have to unbox this object, which is slow, and you don't know what that type could be. You could accidentally try and cast it to the wrong type. So I could then say some pseudocode and then ask for this response. So this would actually call the web server, but for now we'll just make a new API web response. Let's say the server did that and it said, yeah, it was successful, and the response was the number 1. And in our code, because the API web response has just got an object, when we want the number, we then have to do response.object, or response.response. You'd have to do, say, int.parse. You'd have to parse in the response, and then that's your number. I cannot remember object to string. Oh yeah, so you'd also have to get that and then cast it to a string, or you could simply presume the type's correct and actually unbox it directly. So this would work if we ran this. We'd actually be able to unbox this number, but for one, this unboxing takes time and it's inefficient, but we've got the number. The major issue is, say we've just called this in code and this was to get a message, and the developer seems to think it's a string for some reason, or you can quite happily compile, and now you've got an exception. So there's chances of accidentally manually casting things wrong, as well as the fact that you just simply don't get IntelliSense. You don't see what type it is. And then when you times this by 100 different web calls with 100 different responses, it gets nasty. So if you now do generics and simply do T as the return type, say, and you could call it t-response, so you know it's the variable for the response, and you say the response is this. Now in here we have to hard define what we're expecting, so then the API manager that you make that makes these calls will in advance have to specify, well, I expect this to be an integer. So now the server would return, say, this response, and in here we can't cast it to a string because it isn't one, and secondly we no longer need to because it's returned the integer. So now you could have a web call here that's, say, asking for I don't know, get number of friends, and that would return the number. And then you could say there's now also a web response that gets my username, and this would then be Luke. And you can now reuse this web response in the client, and also the server would do the same thing. And then you could even share in a core library these responses as interfaces, so they can share the exact same interface and make sure that they're always returning the right things. And again, that's another real world example, and this can be a lot more complicated than that as well. You can then do custom logic on say returning error codes in here, and then handling error codes, and all the code then for every single web response becomes shared in this class. This class can handle all of them for every response. You don't have to keep checking every single different web response. The only thing you care about is once you get the response, the client could first check that the response from the server is the same as the response we're expecting, and if it isn't, it could set an error up itself. And you see where I'm going with that. It's all about, again, code reuse. So it goes back to the same point that anytime you've got the same logic or the same methods or something that should apply to multiple different types, in this case the response, that then you should use a generic, and then obviously fill out all your logic that isn't generic, and then at the point where you need the generic, you insert it. So that's just another use. And again, these are hard things to explain or give real world examples about where to use, because for one, they're not overly used. There's not a huge amount of times you need them, but in terms of usefulness, you imagine if you didn't have a generic list, then every type of list you wanted in C#, which you use a lot, a list of strings, a list of classes, a list of anything, you'd have to create a class for every one. So even though you don't heavily use them, when you do use them like this is now saving you potentially 100 classes that you'd have to make, with 100 different response types, with 100 similar pieces of code for doing the logic of success and error. And then if you change that code and you weren't using generic, and say you realised there was a bug in the way that you detected a success, you'd have to go and edit 100 classes and fix that code. So hopefully that's been a good explanation of generics. Again, I find this hard to explain because to me it's just sort of natural, and one of those basic things that you always find hard to explain if it is so basic. But if you've got any questions on it or anything's unclear, just leave a comment. And also, I've just changed the code colour to black background to maybe stop people's eyes hurting from having a big monitor with all white space. Let me know what you think about the colour. I can always change it back to white. Just let me know if you prefer the dark theme over the light theme. So hopefully that was useful.